Good morning, learners and viewers. Welcome to the session of Masters of Business Administration. Today we will be talking about project management, MMPO 002. In continuation, today's topic will be related to project monitoring and control, which comprises of this is block 3, which comprises of 4 units. Unit 9 is of project management information system. Unit 10 is project monitoring and control. Unit 11 is project risk management, and Unit 12 is agile project management. We will start with Unit 9, that is project management information system. A project is typically an assignment that has identifiable start and finish and consists of series of discrete finite tasks. Setting up an industry, building a house, publishing a book, or introducing a new product are the small examples of projects. Project management offers methods and techniques for planning and controlling projects. A good project on time and close at to the originally envisaged. Any delay in the implementation delays the anticipated benefits which will which were planned from the establishment of the project. In certain cases, minor delays can often result in major losses. Any increase in project costs adversely affects economic viability of the project. In the cases of large cost overruns, it may not of the project. In the cases of large cost overruns, it may not be possible to arrange sufficient funds to complete the project in time, causing unplanned delays in the project implementation. There are three phases of project management. To start with, that is planning. In this phase, you identify the general requirements of the project, break it down into discrete activities, determine the sequence and interdependence of these activities, estimate resource requirements, and find the critical path. Second one is scheduling. This phase overlaps with the planning phase. You give actual calendar dates to the activities and determine the overall project dates. Calculate the early and last date, start and finish times for each activity of the project. What we have learned in CPM and PERT. And the third stage is the implementation and the control. The implementation phase, which is also the control phase, begins once the project is underway. Here, you employ a variety of techniques to achieve optimization of the resources usage, monitor progress and cost, forecast completion dates and overall project cost, and ensures the critical activities are completed on time. The success of timely implementation of projects depend on the availability of essential information at appropriate time. Normally, the information needed at different levels would depend on the hierarchical structure in the project. In large projects, there could be three distinct levels. For example, the top or corporate level, the journal or executive management level, and the functional or operating management level. The information needs of all these three levels are not the same. Therefore, the information has to be designed in such a way that the needs of all these three levels are adequately taken care of in a project. The information reports are basically used for project monitoring and control with the idea to ensure that the projects are executed as per the schedule and at minimum cost. What are the objectives of project management information system? Mere physical progress reporting and monitoring does not ensure timely completion of the project at minimum cost. Along with monitoring of physical status, another parameters, namely value of the work done and the cost implication of delays in commissioning the project, should also be mentioned. For this purpose, The physical progress of each activity has to be converted into monetary terms using unit rates established by appropriating the cost over all the activities. In designing project management information system, following have to be spelled out clearly. The object of each format or report in brief, the description chart, the periodicity of the reports, the person responsible for preparation of the reports, the source from which information has to be gathered in the preparation of reports. Then comes your planning by network analysis. The basic premise of the project network planning method is that a network can be used to reasonably represent performance sequence of a project. Complexity of the modern projects have made network schedule mandatory for adequate project control. Resource allocation. By using positive float available on non-critical path through the project planner can arrange a schedule of work that accomplishes the result in the same time while smoothing or leveling the peaks and values in the resources to be consumed. Then comes work breakdown structure. In short, we call it as WBS. Project WBS breaks the total task into a logical series of smaller tasks, each of which is chosen for size and scope to fit in with the management structure of the project so that it can be subject to efficient planning and execution. It may be observed that work package is a logical chosen to suit the requirements of engineering, planning, contract administration, and cost control. Each work package carries a duration and cost control. What are the essentials of WBS? Work packages are related to organizational breakdown for effective control and performance measurement. Cost estimates are built up by aggregating the cost of work packages following a logical WBS of the project. Work packages must be related logically to the code of account applicable to the project to enable exercise of effective cost control function. Then comes the most important part, that is the cost control system. Effectiveness of the project cost control system is largely dependent upon the following factors: realistic estimation of cost at initial stage, adequate provisioning for contingencies at initial stages, effective cost reporting system, and timely identification and implementation of effective cost control measures. Realistic estimation of cost at initial stages practically forms the backbone of any effective cost control system. Typical elements that affect estimates accuracy are generally known and well documented in technical publications and elsewhere, although their effect may be difficult to quantify. There will be an element of risk in a cost estimate, for there is no such thing as an accurate cost estimate. What exactly contingencies are intended to cover should be made preferably clear. The efficacy of the project cost control system is largely dependent upon the cost reporting system. Periodic review of estimated cost to completion, what we call it as ECTC, is an essential feature of an effective cost control system. ECTC for each package or activity according to the responsibility centers should be compiled on the basis of actual commitments and likely commitment under processing as well as anticipated commitments to completion of the package activity during every reporting cycle. Adoption of best possible methods for realistic estimation of cost, making adequate provisions for contingency at initial stages as well as having appropriate cost reporting system alone is not enough for controlling the project cost. Identification of problem areas and timely implementation of effective remedial measures only can help in keeping the project cost in check. Periodicity of project cost review should be established on the basis of the availability of the organization to furnish the information required for the cost reporting system as well as the extent of delays that can be tolerated by the management in identification and implementation of cost control measures. Integrated Project Management Information System. As per the diagram, this structure is basically of a typical integrated project management information system. You can see over there are three phases. That is central database system, which is basically a set of data sets. Then comes your processing modules. We have seven data sets. And on the right side, we have information report that means what we are getting from this database when it is being executed. It allows total project information to be structured into a number of datasets which are integrated by the software. Some of the relevant datasets were what I have already showed to you in the figure. For a large projects are drawing dataset, network dataset, cost, material, vendor, job card, rates, resources, history, and many more. Integration of these independent datasets through various processing modules enables high control of project and it permits horizontal integration between disciplines, that is cost schedule integration or cost estimates, cost account, and project schedule integration via WBS. What is work breakdown structure? Then comes your vertical integration. Data can be integrated, rolled up to any required level to produce desired summary reports. Standard processing modules are available for all important project management methods, plus other modules for special requirements. Drawing dataset contains information on drawing, drawing description or title, drawing date, date first issued, subsequent revision numbers and issue dates, and draftsman's name and his department. Management control exercised through queries such as identify all drawings which are not yet approved, drawings which are due for issue in the next 4 weeks, listing of drawing for a specific area of project. By linking the drawing dataset into network dataset, anticipated drawing issues dates can be compared with on-site required dates for various activities. Second one is network data. Vertical integration enables a project to be structured into hierarchical network where a top level network may contain about 50 to 200 activities, and this is driven by a second or third level network having many more activities. Progress information or lower level networks can be rolled up and summarized to the management level network. Third one is cost dataset. This dataset contains details of each cost account. This is based on a predefined or a defined work package with an identified manager and reflects the logical WBS of the project discussed. A large number could contain several thousand records, usually structured so that the cost can be rolled up to show the position on each section of the project and overall position. The field of information usually includes account code or cost code, description of work package, persons responsible, budgeted provision, actual cost of date of work completed, and cost forecast of residual works taking into account change orders, etc. The fourth one is material data set. It contains of the information on the materials required, the dates when they are required, and the manufacturing location for each of them. A typical material management system begins with material takeoff, that is empty, from the drawings, covers the entire bidding, procurement, expediting, and shipping process, and extends through to site inventory control. And some examples of specific functions served by a material control system are material register, inventory control, delivery analysis, bulk order discounts, purchase orders, material quality assurance. These are all parts of material data set. Then we move on further to vendor data set. This provides a required for each supplier, his name, address, telephone, and telex number, and the name of the usual person to contact, and the line of business. The details of past performance will be included for use in vendor rating and initial choice of vendor. The terms and condition of contract, progress, payment, schedule, history of delivery, and many other pieces of information about vendor can all be stored, related, and accessed. Because information relationships can be identified to properly link multiple data sets, data duplication is reduced in the project database. Then comes your job card dataset. Job card carries details of each job performed on the project. Typically, the job card level is directly below network planning in the project hierarchy and facilitates day-to-day planning, which includes job description, budgeted amount, planned start and finish dates, and the resources required for executing the job. It includes procedures for progress control, effectively provides the mechanism for allocating work, collecting project information, and updating the rest of the project system. A large organization engaged in a large number of power projects has evolved a system of information reporting covering the project as a whole and construction activities separately. Moving further, we take on project monitoring and reporting. In order to keep track of the project status and head off problems before they occur, it is important to regularly report activity progress. Different parts, different compositions are there, and different types of reporting are there. So we will start with project monitoring reports, which is overall status report. It can be monthly status report, daily report assessment, or township progress report. It can be of any form. Then comes your value report, format for contract cost allocation. Activity cost breakup is included in it. Record for compilation of value of work done in terms of project, summary of value of work done at site, report on value of work done from the site, contract progress report, and the project value. Third one is contracts, which is basically schedule for contracting activities, schedule for milestone activities, contract package wise activities, contract progress summary, departmental performance summary, contract progress summary, or delay reports in the contract. The fourth one is contractor's work, activity schedule. Contractor work, what he has done and what he is supposed to do. Physical progress summary. which is again related to contractors. Bulk material procurement progress. Delay reports in terms of contractors' waste and schedule activities. Infrastructure. It is related to a schedule for site contracts, site contract progress summary, infrastructure progress report, and summary. Second part is management report. The fundamental principle on which the management reporting structure is to be built up is the exception basis of reporting. The system must provide for comparison of actual performance and expenditure with plans and budgets, and an analysis of deviations from plans reason wise. To a large extent, the report should highlight information for effective control on quantity, time, and cost of activities within a function. In certain areas like rejection of incoming material which are not planned, the reporting would not be against budgets or targets, but in absolute terms. The reporting system assumes a comprehensive system of performance, budgeting, and activity planning. In designing the reporting systems, the activities of the undertaking have to be broken up functionally according to the concurrent and planned organization structure and further into sub-functions depending on the nature. There are services and materials which are also included in this reporting system. If we talk about the technical services, it is the status on project engineering report, contract status report, and achievement of objectives report. Second one is materials, which is related to inventory status report, inward rejection report, material issued to contractors report, delays in procurement report, delays in supplies report, and demerge paid report. Third one is construction facilities, which includes construction equipment control report, construction utilities control report, maintenance report, and auto-based control report. Fourth one is related to personnel, which includes manpower and recruitment report, staffing report, training and development report, manpower cost report, and divisional manpower cost report. Fifth one, that is the most important part, is related to finance, which includes funds report, loan utilization report, payment to contractor report, cash flow report, cash flow analysis report, divisional cash flow report, indirect expenses report, indirect expenses analysis report, and divisional indirect expenses report. Now we move to Unit 10, that is related to project monitoring and control. As the name suggests, here the position is that the project is undergoing. We have to monitor it and we have to see how the things remain in order as it was planned initially at the beginning of the project. Today, in organizations, managing projects successfully have become one of the most critical aspects. Competition becoming fiercely daily and completing project on time with budget and of good quality requires controlling and monitoring of the project activities. Project monitoring and control aims at minimizing the deviations from the project plan by comparing them with the plan, analyzing the deviations, and implementing the appropriate corrective actions. Monitoring is basically about collecting sufficient data to measure progress and make sure that the project team implements the plan correctly. Whereas control is the process of ensuring that the project delivers everything as intended according to schedule, cost, and quality by taking corrective action. These are the basic key elements of project control. The thing is that what to control. If we talk about the scope and performance, it is unexpected technical problem, specification changes, and interfunctional complications. If we talk about the cost, which we have to see initial estimates and what is the budget for that. Time, in terms of time, it is the initial time estimate and the time sequence. If we talk about the quality, it is the technical quality, external quality requirements, internal quality standards that is within the organization, and customer expectations. Then comes your risk. Risk, no doubt, of two types, that is internal risk and external risk. And for the team, it has to be motivated and a proper enthusiasm has to be kept. What are the types of project control systems? One of the challenges in project is that the project manager faces multiple objectives, goals to be accomplished, and monitoring their progress becomes therefore critical. For every goal or objective, at least one performance measure is needed. It is well established that the project is designed to be on time with budgets and should meet performance standards as set or needed by the customer. Thus, the project control system can be classified as one dimensional control system and multi directional control system. Initially, we will talk about one dimensional control system. It is basically used to control specific issues dealt with as a single dimension, and thus the objectives are not integrated. Whereas in multi-dimensional control system, integrate several project objectives. Project monitoring and control plan. The project monitoring and control plan is developed during the planning phase and includes basically three steps. First one is outline the project, that is, establishing scope, schedule, and budget baselines and defining milestones. Second one is creating a breakdown structure, creating a clear picture of task, subtask, and deliverable to manage work. And the third one is executing the project plan. That means reporting and analyzing the variances, determining the variances and their acceptability, and taking corrective actions for unacceptable variances. There are many ways in which information about the project work may be gathered. It can be in the form of team meetings, regular progress reports, or specific technical meetings. It is critical to note that information required by the project manager must be timely, clear, appropriate, and correct, and the progress should be spotted as early as possible. What is the frequency of reporting? Reporting of the event can be event based, that means at the end of a particular stage of task, or time based, that is at the end of a particular time period, or deviation based, where there can be a deviation from the plan outside the agreed tolerances, or a problem based when there has a significant unplanned event or occurrence of a known or unknown project risk. Then comes your type of data to be reported. Data such as effort utilization, that is man hours, cost, elapsed time by task, work package completed, task completed, milestone achieved, equipment usage and changes considered should be collected for monitoring purposes. Schedule and cost forecast are normally presented as the reflecting status of the project, that is on track, ahead, or behind, typically expressed on scheduled variance, what we call it as SP, and the cost variance, that is CV, which are discussed in later part. Project monitoring and control plan. The project monitoring and control plan is developed during the planning phase and included basically of three steps. That is outlining the project, creating a breakdown structure, and executing the project plan. There are many ways in which information about the project progress may be gathered, which can be in the form of team meetings, regular progress reports, specific technical meetings. Now, what is the frequency of collecting data? The question comes to how frequently the data should be collected. It is suggested to assess the work progress every week. For small projects with work package lasting only for 2 3 weeks, progress should be monitored at least twice. For projects with work packages lasting for several months, assessment every 2 3 weeks might be adequate. That means the frequency of assessment has to be defined by the project manager or the manager. Now, this is thing is that how it is studied. So now we will talk about Gantt chart. During the execution of any given project, the project manager seeks the following answers. Is the project going ahead or behind schedule? What is the present status of the project in terms of cost and schedule performance? How are the cost performance and schedule performance of the project? Based on the current performance, where would be the project be finished? What is the overall cost of completing the project? These are some of the basic questions which comes into consideration by a project manager. The Gantt chart and earned value management, that is EVM, provides the answer to the above. It is one of the most used planning and controlling tools in project today, depicting the work schedule to be done on specific days with start dates, end dates, and milestones of the project. Project tasks are presented on a vertical axis, and timelines that represent task duration are presented in horizontal axis. Mostly, Gantt charts are created in Excel or with project management software. Now the question is, it was proposed by Geraldine Lecter that where to use Gantt charts. So here we can see where Gantt chart is used. What are the conditions and what are the basic, the principles and the questions which comes into the mind of the manager. Principle is related to time focused. Is the project mainly time driven? That is the focus on time proceeds. Other performance area of a project. If what is the objective? Can the task of the project and its duration be described precisely, unequivocally, and inconstantly? Deterministic. Is the project mainly a routine project and uncertainties are not really expected? Analytical. Can the project be easily broken down into parts and the interface and interdependencies can be clearly defined and coordinated? Does the performance of the project equal the sum of the performance of its parts? Next one is accountable. One can establish clear accountability to different parts of the system. Sequential. Do the activities have a natural linear sequence? Is it expected to get back each task right the first time without the need to revisit it? The questions presented in the table assist project manager in reflecting on the appropriateness of the Gantt chart for their specific project. If many of the questions are answered yes, the project manager should consider the use of Gantt charts to manage the project implementations. However, in situations of high ambiguity and low objectives, Gantt chart can act as an instrument to negotiate consensus and understand different perspectives of the time duration across different groups of stakeholders instead of imposing a reality to the project. Now, it is earned value analysis, EVA. Earned value is the classical multi-dimensional project control method used for monitoring two dimensions, that is time and cost. It compares the planned work with accomplished work in terms of monetary value assigned to the work. Here, when the activity is completed, the value of activity will be considered as earned. Given a baseline, project manager and their teams can determine how well the project is meeting in terms of scope, time, and cost goals by entering actual information and then comparing it with the baseline. The baseline information includes scope data, which is related to work breakdown structure. Second one is time data, which is related to start and finish estimates of each task. And the third one is cost data. That means the cost estimated for each task. Work breakdown structure, what we have discussed earlier, that is WBS, is a deliverable oriented grouping of project elements, hierarchical structure, defining the total scope of the project. The work package is the lowest level of a WBS and it includes a set of tasks to be carried out and are used as the basic element in the planning and control phase of a project. What are the key terminologies which are used for variances? First one is cost variance. It is denoted by CV. This determines whether the costs are higher or lower than the budgeted. A negative CV means the project is over the budget, and a positive CV means the project is under the budget. Then comes your schedule variance, that is SV. SV determines whether the work is ahead or behind the planned schedule. A positive SV means the project is ahead of schedule, and a negative SV means the project is behind the schedule. Then comes your planned value. Planned value is the budgeted cost of work that has been authorized for a scheduled activity or WBS component during a given time period or a phase. These budgets are established during the planning process. All PVs add up to the budget at completion, that is BAC. PV is also known as budgeted cost or work schedule, what we call it as BCWS. Actual cost. Actual cost is the cost of completing the work component in a given time period. AC measures the cost, which can be direct, indirect, or other, that were used to calculate the planned value. It is also known as the actual cost of the work performed, which is ACW. Unvalued. It is measured as budgeted dollars for the work performed. EV is typically expressed as a percentage of the work completed compared to the budget. It is also known as budget cost of work performance, that is BCWP. Now, what are the mathematical relations between all these terms of the variance? If we talk about cost variance, it is BCWP minus ACWP. Cost variance, it is in percentage, that means it will be a ratio, CV upon BCWP. Cost performance index, again this is a ratio because it is, by the name suggests it is an index, so it will be a ratio. It is the ratio of BCWP and ACWP. Schedule variance, it is BCWP minus BCWS. Schedule variance, again it will be in percentage. It is SV upon BCWS. And schedule performance index SPI is BCWP to BCWS. It is important to consider the variance both at the product level as well as the work package or activity level. The project manager should check both levels of access, the project status. If only project level is considered, a good performance of some activities may hide the low performance of other. If only a work package is considered, the cumulative effect of slightly poor performance in many activities can be overlooked. Once deviations are identified, their corrective action, if required, is taken, such as no action is taken if the variance is small, revising the original plan and replanning activities in light of the current situation. And the third one is terminating. EVM provides small advantages, such as it integrates time and cost aspects of the project. It works as an early warning signal that can help project manager in making decisions and corrective actions. And thirdly, it provides a better understanding of the project status. When project manager understands the status of the project, they can implementation and testing. TPM has planned value and definite time increments against which the actual values are plotted. Monitoring TPM, it provides visibility of actual versus planned performance, and it also provides early detection of problems requiring management attention. There are considered the most basic forms of technical measures, and if not achieved, may introduce cost, schedule, or performance risk. For example, performance measure includes reliability, power required, weight, throughput, human factors, response time, etc. TPM is created for projects with the following characteristics: high priority requirements that impact mission accomplishment and customer satisfaction, high risk requirements that have a high probability and consequences of failure, requirements where the performance is expected to improve, the time where progress towards the goal is expected. Then, the requirements where the performance can be controlled. It is noted that technical performance measures, when evaluated over time, must either decrease or increase to meet performance requirements. Now, we move to Unit 11, which is related to project risk management. That means here we will be talking about risk factors in projects. A project is a series of tasks that needs to be completed to reach a specific goal or outcome. It can also be said as a set of inputs and outputs needed to achieve a specific goal. Some important characteristics of the project are: it has a purpose and results normally in terms of cost, performance requirements, and schedule. Projects are temporary activity, that is, they have a fixed time frame. Every project is unique. Some of the activities need to be modified due to changes in the laws, location, time, people, etc. The project possesses a significant element of uncertainties and risk due to changes in circumstances and technology developments. Project pass through several distinct phases called project life cycle. The role of a project manager is considered to be highly critical while defining and shaping the desired targets of project execution. A project is considered successful only if it achieves the specified project objectives. It is important to remember that not only within time and within budget are the measures of project success, but measures such as efficiency, impact on customer, impact on the team, business success, and future aspects that project creates are critical to be considered. Project success is a multi-dimensional construct that embarrasses long-term achievement, that is, desired effectiveness and impact of project results, and short-term success in terms of project efficiency. The Project Management Institute PMI Pulse of the Profession 2021 reports that only 55% of the projects are completed on time and 12% of the projects deemed failure. The specificity of the project, more frequent changes, pressure to meet the project deadline and budget, and meeting customer expectations with limited resources makes a project team more challenging as compared to leading teams in traditional organizations. What are uncertain and project risks? The world and the environment in which the projects operate are not deterministic in nature, and many uncertainties are faced. Uncertainty is a state of mind characterized by a conscious lack of knowledge about the outcome of an event. Uncertainty is a situation in which it is not possible to specify numerical probabilities. Uncertainty in the project may be associated with estimating project parties and stages of the project life cycle. Risk is an uncertain event that matters if it occurs has a positive or negative effect on project's objective. Or we can say risk is the project in the project is one which creates a situation impacting the project team's ability to achieve the outcome of the project exactly as planned. It is an event likely to occur in future during the project life cycle. The key elements in terms in this definition is uncertainty, which refers to the situation under which either the outcomes and or the possible probabilities of occurrence are known to the decision maker. That means we can say that the probability of occurrence is unknown. None of the projects are risk free. In general, the level of risk depends upon two factors. One is the uniqueness of the project, and the second one is the experience of the project. Uniqueness is usually linked with uncertainties and unknowns. Risks are present in all projects, whether big or small. One of the other risks will always be present from the concept to completion and operation of the project. For the success of the project, it becomes important to eliminate or reduce the effect of risk, and therefore it requires attention and action at earliest. The purpose of risk management is to enable project progress towards organizational goal and project objectives in an efficient and effective path through maximizing the uses of available resources and deliver target consistently in a sustainable manner. Project risk management seeks to increase the probability and impact of positive events and to decrease the probability and impact of negative ones. Project risk varies from project type, industry, experience in managing similar projects, as well as scope and size of the project. The risk management plan depends on your organization and stakeholders' risk attitude, which is what extent the project manager and stakeholders are willing to take risk. There are different kinds of organizations outlook towards risk. First one is risk averse. The organizations who are cautious in situations of large losses. They are reluctant from project decisions, even if project decisions might also offer a possibility of large gains associated with success. This behavior is known as risk averse. Then comes risk neutral. Such organizations keep a balance towards the utility and the payoff. Such organizations weigh all pros and cons before deciding to take risk or not. Risk seekers, they enjoy and find it challenging to deal with risk and accept risk as a normal feature of the project and business. However, this excessive optimism may sometimes lead to losses due to giving less importance to the potential effect of the risk on achievement of objectives. Now, graphically, we can see there are three graphs, which shows the first one shows the risk averse. It is a graph in terms of potential payoff and utility. It is a graph which is moving up and then it is taking a cut. As far as the neutral risk neutral is concerned, so it is an equally inclined line between utility and payoff, potential payoff. And in the third one, which is the risk seeker, they normally take the risk, so that means it is moving upwards. Risk management process. Risk management is a formally structured process for systematic risk identification, analysis, and response throughout the lifespan of the project in order to achieve an optimum level of risk elimination or control. The process of how to conduct or do risk management activities is called risk management process. The process has some phases, that is identifying as many risks as possible, analyzing risk in terms of impact on the project goals and its likelihood of occurrence, responding to each potential risk if and when it occurs. Fourth one is changes in project plan to acceptable. That means if no doubt if the project has stakeholders, they have to be taken care. Level to account for certain risk. Monitoring and review to have a check on risk control actions. Here we can see that what it was provided by Cooper. It is a risk management process. You can see six squares which have different stages. If we start with risk management planning, where planning the risk management activities concerned. Moving further, that is risk identification. What can happen and how long will you see? How will you see it coming? That means qualitative risk analysis. What is the probability and the impact scales on priorities? Further analysis is required. Then we move to quantitative risk analysis, which is quantification of the individual risk. That means we have to find the aggregation of overall risk to the project. Further, risk response planning, which is how to deal with the risk. That means a plan for dealing with risk is made. Residual and secondary risk. And the last one is the contingency level. When all these have been followed, the last step, which is risk monitoring and control, which is maintaining the assessment, and plan up to date. Collective decision making is very vital in project management that can make or break this part of the work. Almost all risk management activities will involve meetings between the project manager, the team, and other stakeholders in order to make decisions about various activities, risk, and associate estimates. Now, there is a table which shows the responsibility of various stakeholders involved in the project. It should be noted that it is not only the responsibility of the project manager towards risk management. Now, if you see that, we talk about the risk activity. First of all, risk identification. That means the question arises who is basically responsible to monitor it. We are talking about the risk management, monitoring. Different types of risk are there and who is basically responsible for taking action. Risk identification, no doubt it has to, it is the responsibility of all project stakeholders. Risk registry, it is project manager. Risk assessment, all project stakeholders. Risk statement, project manager's team, communication. Risk response option, identification, all project stakeholders. Risk response approval, team communication, recommendations, project directors. Risk contingency planning, which is the job of the project manager. Risk response management, again project manager. And risk reporting, that is project manager. When dealing with the project and looking at uncertainties and risk, following questions about the project should be looked at along with their answers. Who are the parties ultimately involved? What do the parties want to achieve? What is that each party is interested in? Which way, how in each party wants to be done? What resources are required? And when does it have to be done? Use of six questions from the earlier stage of the project life cycle can provide information on development of project design and logistics by clarifying key sources of uncertainty. With this, we will be concluding today's session.